them then. Our next presentation is a look at the biological treatment of wastewater and biogas. It's going to be given by Mr. Sudeep Sangamaswan, who is the Managing Director of PAC Environmental Technology here in India. So I'd like to pass the floor over to you, please, Sudeep.
Thank you, Max, and thank you all the distinguished panelists who spoke before me. A very interesting presentation, especially because it covered a lot around municipal and public water space. The space where Parks plays is a little bit different because we are primarily in the industrial wastewater treatment, industrial wastewater to energy space. We do have a small footprint in the municipal, so it was extremely interesting for me to see the previous presentations, and thank you very much. And also thanks, I see already 507 participants watching, so it shows that this is the this is going to be the the future template of all such seminars where we get more people, more eyes, more people involved, post-COVID world. So also thank you for all of you for watching in. Opening remarks, so I just quickly move on. Parks is a Dutch company, maybe about 50 plus years old, so a lot of history. We are partially owned by the same family that also is the majority shareholder of the BMW, so we also have a German connection. We are present in about 60 countries, either through own offices, factories, or partners, about 400 employees, because we're a core technology company, not a contracting company. And the core technology is around wastewater and gas treatment using a niche area, anaerobic treatment. So we are pioneers there, worldwide presence, and the vision is world without waste. So if I could move to the next slide, please. And I myself am part of the global leadership team of Parks, but I also run the India and Middle East part, including the factory. We have the most modern Parks factory because it just happens to be the newest in the southern part of India. So this, I just quickly, I will run through a few slides just showing how innovations just can be scaled up quickly into a global technology solution. So from a Dutch, we come from a region in the Netherlands called Friesland. It was a provincial business. We used to make silos. And from there, we moved on to becoming a biotechnology player in wastewater treatment with factories in Brazil, in China, India, and of course, the Netherlands. Next slide, please. The vision, mission, I'm just going to quickly run through all this because it's all available on websites. So if you would permit me, in the interest of time, I will just go on to the next slide. Because what I want to really talk about is how Parks has been the front runner in industrial and anaerobic wastewater treatment since the early 90s. We really, in this space, in this niche space, we really hold a runaway leadership position, if I could use that word. Almost more than 1,500 installations worldwide, largest player by market share, and continuous investment in R&D, which ensures that, you just like you have 2G, 3G, also the 4th generation now. So COD is our bread and butter, COD in wastewater, and primarily industrial. And if I move on to the next slide, please. And most of the people who work with anaerobic technologies in the niche, they do see Parks as a global leader. And that's really one of the ways of realizing how small ideas from lab scale can be really taken to the global level as a sustainable solution. And if I could, these are the slides from the Global Water Intelligence. I'm going to quickly move to the next slide, please. What I wanted to talk about is how, any Western technology, when it is really proven, and in India, if you do it the right way, and the right way I would say is, plant your feet firmly in the ground, it's very easy for any Western technology company to get accepted in India. So we started primarily in 2013. Most of the team came from another Dutch company which we had set up in India. Probably some of you may already know Norit. I was the one who set up the Norit business in India. So after that, so most of the team came from there. So we have a background in membrane treatment and carbon and wastewater and clean water technologies. From the time we established a sales office and then to the factory, and in 2008, so in the span of 5 years, we got the leadership position in India. Not because we are doing anything great, but it's just that the country and the industrial consumer in the country is really keen on accepting technologies where he is able to see a bang for his buck. And at the same time, he gets this technology at locally relevant pricing and locally relevant technical support. So this is the key takeaway from this slide. And if I could move on to the next slide. Yeah, there you go. So innovation and valorization. So this is just a quick run through how we moved from the conventional sludge blanket reactors to the vertical reactors, the thiopacks for sulfur treatment, nitrogen treatment. The U-box is our play in the municipal space, and of course the latest generation of anaerobic reactors, which are the most popular in India. I would say they are the de facto standard now in industries like paper and pulp, sugar, distilleries. And yes, we're very proud of saying this. We have invented practically everything that we sell. Next slide, please. Thank you. These are the challenges which also fellow panelists earlier talked about us. And we think that in the industrial space, companies like us have a great thing to offer to close the sustainability cycle in terms of the water footprint as well as reclamation of resources, because most of the COD-rich wastewater energy is already available in the form of biogas. And I know today's research is looking at much more than just reclaiming biogas. They're looking at reclaiming much more valuable nutrients, much more valuable things like bioplastics. So I think this is going to be a very, very important play. Nature has enough, and the waste is nothing. Nature has enough for us to close the loop and sustain our civilization. So next slide, please. So we have really we were just mimicking nature. We are just using creating circumstances when nature is able to accelerate what it can offer. And like I mentioned earlier, anaerobic digestion is what we do, the core. But we also have proven and working industrial scale technologies in ammonium removal and also in gas desulfurization. And now the future, as I said, it's not about biogas, but it's more value-added products which can be recovered from what people call waste, bioplastics. So Parks is also in the forefront of research in areas like this. And that is probably when we move on in the evolution cycle also how industries accept wastewater treatment. They begin seeing great value in it, not just as something to meet the pollution control norms. Next slide, please. And this is what I was telling in pictorial terms. What I was telling yesterday, how we do batch tests, bench scale, and this is really the innovation cycle which most small but technology-intensive companies like us go through. And the most important thing is how you can sustain it for a long period of time, commercially, technically, the bandwidth in terms of management, finance. And once you do that, then once you have scaled up and you've done 1 or 2 commercial installations, then the replication is very, very easy and it's global. So because there was also a look at innovation and how innovation is taken to the market, I read about it in some part of this seminar when I got the introduction, so I thought I should use this slide. Next slide, please. Yeah, so from pre-treatment to aerobic treatment, Parks has got a play in almost every part of in an industrial effluent. Primarily, we are in spaces where the industrial industry's raw material is predominantly of agrarian origin. So paper and pulp, sugar, food and beverage, vegetable food processing, seafood processing. These are the areas where, so COD, high COD loads come in. Parks has technology for almost everything, including Biopack is where we purify the biogas and then it can be used in gas engines or it can be even bottled and sold. Next slide, please. Of course, services is an important part, and we cannot, what we are moving and we are seeing, especially in a post-COVID world, is the importance of remote sensing. So you'll see a product called the Sensor Track, which places a lot of monitoring and preventive maintenance power in the hands of the engineer just on a smartphone, a lot of analysis. So I think this is going to be, digitization is going to be a major part also in our industry, and Parks is investing heavily into it. And also, again, another observation I have is all these technologies, the Indian private industry is very keen on adapting. It doesn't, the hurdles to adoption of these technologies, once you convince them, are very limited, even though the price in the beginning may be to the Western standards, because when you start with something, you don't indigenize it immediately. So that's really a good feel we have about the Indian consumer. Over the last 5 years we have been in India, that his openness to spending money on really relevant Western technology and implementing in India. I'm talking of the private entrepreneur. If you can go to the next slide, please. So these are the main industries which are where the wastewater is really a resource-rich component of the whole business, and not just to be looked at as wastewater to meet discharge norms. Paper, dairy, food, sugar and distillery, brewery, and in all these sectors we have close to, in the last 5 years, we have close to about 50 references in India. So in various stages, some commissioned, some repeat orders, some in process of being commissioned. So that's really how, I cannot, get tired of repeating it. There's always a place for good technology, even in countries like India, which may be a little bit late in the adoption of modern technologies. If I go to the next slide, to remain at the cutting edge, the industry academic cooperation, that is the biggest driver. And that, of course, I saw my colleague also from the Netherlands earlier who gave the keynote address. All these universities, some of the best universities in the Netherlands, we're very thankful for the kind of research work, application development work that goes on. And this ecosystem is what really ensures that we are able to stay ahead of the curve. Next slide, please. Few key clientele, all global names. Also, you will see a couple of really strong Indian companies. Gadre, if you know, is one of the biggest seafood exporters from India, standardized fully on Parks anaerobic technology ever since we came in. I think we've done 4 or 5 projects with them. Also, the South India Paper Group. So it's a very nice fit of various industries where the wastewater is rich enough to allow us not to call it wastewater. Next slide, please. Okay, these are just pictorial things which are available on the website. So I'm going to skip through to the next slide. A typical reference from a dairy. Dairy is also one of our biggest space in India too. But this one is in Mexico, working from 2013. And look at the load of COD treated. So I have a few slides, so I think you can quickly keep clicking because it shows the various industries where anaerobic treatment can generate biogas. Yeah, the Ben & Jerry's ice cream, very famous brand in the Netherlands. Sugarcane, very big segment for us also in India. Whiskey production. Smurfit Kappa, which is a very famous case study if you're in the recycled paper plant business, where it is a closed loop system. The whole water runs through but the COD gets stripped off. And this is something which is being implemented, I think, across about 10 or 12 projects in India now. This is a very big group, sugar group, for parks, distillery wastewater treatment and sugar effluent treatment. This is a big thing. I think this group alone, this DCM group alone, we have something like 5 or 6 installations. So once a client gets into using high rate reactor anaerobic technology, I think it just shuts the market to the older technologies. That's really what it is about. And in India, we are not just a technology player, we are also an end-to-end solution provider, because we realize that if new technologies have to be introduced in India, you have to somehow put your stake on the ground. So in India, we also function as a contractor, where we do the full end except the civil works. So that is also one of
2 minutes, please, Sudeep.
Okay, so then we quickly go to, I just have these kind of slides, which are case studies. Why I'm highlighting this is if anybody is from any of these industries, we have detailed case studies, and they just write to us, and we'll be glad to share this with them. This is the beating heart. I've already covered this, the anaerobic bioreactor. And if I can move on to the next slide, please. Yes, so that is really what I wanted to cover, the extent of the technology, very niche, but very well respected in industrial wastewater treatment, where we convince people that industrial wastewater is a resource, is as resource as their raw materials. And this is a picture of our factory in Sri City in the south of India. It's one of the, I would say the best wastewater treatment manufacturing facility in India. And I have lots of people who visit us tell us this. So anytime you're in the southern part of India, I'll be happy to host you here. Thank you very much.
Thank you, Sudeep, for that fascinating look at an innovative technology company which has played a leading role in transforming the way in which we look at waste. Again, there are a number of questions, but unfortunately, as we're running late, we're going to have to forward those to you. Our final presentation in this session this afternoon is from Jochen Henkel, who is the technical service specialist in membrane applications at DuPont in Germany. He's going to talk to us about the Dewatering water reuse concept, which was a project that started as an internal project in Dow and has grown into something to embrace the wider community. So here to tell us about it is Joachim. I'd like to pass the floor over to him right now.
Thank you, Mark, for the introduction. I hope you can hear me clearly. Greetings from Germany, and again, a Dutch story to tell. Besides PAX and KWR, I see that Dutch technology is very much represented here in this field. So I want to talk about the Dewatering water reuse concept for the next 10 to 15 minutes.
Joachim, I think you are on mute. Can you unmute yourself?
Okay, now I'm unmuted again.
Yes.
But I don't have the control.
Ram, can we share the control with you?
Okay, now it's skipped. So for those who don't know DuPont or our business in the water business, not yet, maybe you remember that 2 years ago, Dow Chemical and DuPont merged together, and the water solutions team from Dow Chemicals moved to DuPont. In principle, all the products stayed the same. So we are still manufacturing reverse osmosis, ion exchange, and ultrafiltration. And since half a year, we also include membrane bioreactor technology, membrane aerobic bioreactors, membrane degasification technology in our product portfolio. But this is about the Dewatering project we started 5 years ago. And then I want to say thank you to my colleagues, Mark Slug, Niels Groth, Jörg Trumpe, and Wilbert, all of them from the Netherlands. Without them, this project would not have been possible. And as you see, it's an interdisciplinary approach. It's not only about products that was mentioned before, it's about working together, finding solutions with the different disciplines in a big company. Let's start with the year 1979. Have a look back. At that time, I was 4 years old, and Dewatering started with a water review, which I think is amazing to see that already at that time they were thinking about reusing wastewater for their purposes inside the company. This is a screenshot from a paper that was produced at that time. You see it's still typewritten, so no computer was available to write it down. And amazing from my perspective is at that time, 79, they already thought about skipping the once throughput industrial water cooling, which is today still a topic in the industry. They also thought about reusing waste streams for cooling towers, which is still a topic of today. And more amazingly, handwritten additionally to the typewriting, you see RO. At that time, 79, the polyamide flat sheet membrane was not yet invented, but still polyamide hollow fibers at that time produced by DuPont were available. And so they had to write it down by hand to evaluate that technology, which today is common sense for water reuse in the industry. Now, the next big step was then 2001. At this time, we included the wastewater reuse from the sweet wastewater part for the cooling tower. We separated wastewater that was low in conductivity and low salt content, and we separated it, the wastewater that was high in salt content. So that was actually the start of wastewater reuse for the cooling tower at that site. Now, since then, 20 years later, 2019 again, this is the current state. So today, this is the Dewatering wastewater reuse, how it is acting today. I will not go into details because this has been presented by Niels Groth several times. You will find detailed information about it. So it's just showing that we use 3 different types of waters. It's surface water from the BISPOS, it's wastewater from the municipalities, and it is wastewater from our own wastewater treatment plant. This graph is showing that meanwhile, the water consumption on site has decreased significantly. And this one shows that this work would not have been possible without the integration of all shareholders like the city of Terneuzen, like Dow Chemical, and our partners Avides in the Netherlands. Now, this approach has achieved a lot of attention in the industry and also got several awards. But I want to show you also some challenges that are then related to the operation of such a wastewater reuse concept. It's not just about the idea, it's also about how operational is the idea then finally in practice. And I selected 2 cases, and one is the reverse osmosis plant at the Deco site that treats the water to produce makeup water. And it's reusing the wastewater from the municipalities. So it's a double pass RO with 2 trains. It uses now MBR effluent from the municipal wastewater treatment plant, which is delivered by a 13 kilometers pipeline to the site. Now, the characteristics of this water is it is high in biofouling, particulate fouling, and scaling potential. And the consequence is that the plant, the RO plant, has to be cleaned 200 times per year. Now, you know that the year has 365 days, so that's a number, 200 times cleaning per year, more than every second day, 1 train or 1 stage is cleaned. Still, the membranes last more than 4 years in operation. That's also an achievement. The second example is the cooling tower operation, which gets the wastewater from the internal wastewater treatment plant, which is just then filtered before it's then used for the cooling tower. So here we are, of course, limited to some operational parameters, which are, for example, the Legionella concentration, like, for example, the suspended solids concentration, ammonia concentration, BOD concentration, and conductivity. all in all, these internal parameters that limit the application of that water leads to the result that only 40% of the annual volume that is available from the wastewater is actually used. All the other times it has to be supplemented from the BISBOS, from a surface water. So this were the challenges. And 2015 was a good time to sit together and think about, because the company itself set itself some new sustainability goals, and a new contract has to be established for the next 20 years. So sustainability goals were, for example, to remove or reduce the BISBOS water, so the surface water intake. And another goal was to reduce the water consumption by 20% by 2025. From the new contract we expected, which is now given to Evides, that demineralized water is supplied, and that, of course, there's also cooling tower makeup water of high quality available for the future. So the goals that when we set together for the water reuse concept were then following that we will increase the wastewater treatment plant effluent reuse from 2 to 4 million cubic meters per year. Additionally, we will increase the wastewater reuse from the municipal wastewater treatment plant from 2.5 to 3.5 million cubic meters per year. And last but not least, we also want to use 0.5 million cubic meters per year of rainwater. At the same time, we want to reduce, of course, the cleaning frequency, which is obvious. You don't want to clean 200 times per year, but less than 12 times per year. That is what we set for our goals. Reduce the chemical demand for the reverse osmosis and the cooling tower by more than 50%. And finally, also increase the reliability and the maintenance of the heat condenser and the cooling tower. Now, there are different solutions for every challenge that you are facing in the water, and that is generic for any kind of water that you want to treat. And you should go through these challenges depending if they are present of the water source. But our source of water, the wastewater, the treated wastewater, had a biofouling potential, had organic fouling, had particulate fouling, and scaling problems. And you see on the right side just some technologies that can tackle those challenges. And now it's up to us, to the experts and to the OEMs, etc., to build a concept that fits best to the customer. In this case, we were ourselves our customers at that time. And the final approach that we put together looked like this. So we want to test a first treatment with wetlands, and we hope that the wetlands will make the wastewater less bioactive and reduce the BOD in the feedwater to the plant. And at the same time, we want that the wetlands work as a buffer, so that they can save and store water for times where the wastewater treatment plant may not support as much as we need. The ultrafiltration should take care of the suspended solids, take away suspended solids, and have then a free suspended solids feed to our ion exchange process. Now, this is just showing one column. In reality, it's a little bit more complex. We want to take out the hardness and the organic matter so that we don't need antiscalants to feed our reverse osmosis plant and get high quality permeate. At the same time, we also want to have a high quality concentrate. The concentrate typically is seen in this picture as a waste, but we don't want to use it as a waste. We want to use it as a resource. So this concentrate is later on then used for backwashing the ultrafiltration and for regenerating, partially at least, the ion exchange resin. And depending also on the quality of this concentrate, we might even produce a product. But this will be seen how the pilot plants will work. Now, pilot research progress. Of course, you don't put a large scale in place if you're uncertain about certain technologies. Here on this picture, you see the wetlands, how it's looking now. So it's built for 10 cubes per hour, if I'm not mistaken. And just 2 months ago, the full pilot plant went into operation. Here you see now a picture of the time that we have foreseen to test the different technologies. So from 2020 on, the ultrafiltration, the ion exchange, and the reverse osmosis plant should be in operation, the pilot plant, sorry. And then from 2020 on, we want to test the constructed wetlands in combination of all the technologies. Lessons learned, and we have learned a lot. So what is still sure is that water reuse, despite the challenges that we observed during the last 40 years, is cheaper compared to seawater desalination, because that was also an option for the Dewatering plant and was even installed there previously. Now, this all could not be achieved without the interaction between the different responsibilities, like the water board, the water supplier, and the technology supplier, and the end user. We were lucky because we had manufacturing inside. We had the technology supplier inside our own company at that time. As I said, we once belonged to Dow Chemical. So that facilitated exactly the exchange of information tremendously. Yes, the biological stability of the water is key for any wastewater reuse project. If that is not given, you face a lot of problems. You have seen that with the reverse osmosis plant that had to be cleaned 200 times per year. So the real value of that water is not just in the technology. Of course, that way that we put together, that's what you have seen, the ultrafiltration, the wetlands, the reverse osmosis, all this together, of course, is much more expensive than just a simple sand filtration process. But the value of what you create through the high quality of water, which is then transferred to the cooling tower or then to the heat exchanger, is much higher than the cost for that treatment that we implement. Yes, and although it looks complex, it's actually not the complexity of a system that is difficult to handle. It's rather the number of problems that the system is causing. So although the simple reverse osmosis, I say simple reverse osmosis plant that is now installed and is cleaned 200 times per year, of course, is much more difficult to handle than hopefully the solution that we have developed now that will have to be cleaned less than 12, hopefully only twice per year. And then this is already the end of the presentation. You really need to understand the technology and its advantages, and often one technology doesn't only offer one item. If I take, for example, lime softening, of course, can reduce suspended solids, but it also reduces silica. It also reduces or removes organic matter. So there are multiple aspects that you typically have to understand that are included in one process to really get the full knowledge or the full applicability of this process and adapt it into a concept that finally and hopefully works well in the end. And with that, I say thank you, with a quote from Einstein that says, we actually cannot solve our problems with the same thinking we used when we created them. So it's very much about getting out of our silos and looking around and talking to people, trying to understand their problems or their solutions, and then work together. And together you are able then to create a very good solution for everyone. Thank you.
Thank you very much, Joachim, for that look at the Terneuzen project. I guess from what you're saying with that last quotation is that with all of the fantastic technologies we've had a look at during this session, one of the most critical factors in implementing a successful water reuse project is to effect some not only technological change but cultural change throughout the organization in terms of all of the players need to buy in. Would that be correct?
Yes, certainly true. For us as water technologists, it was a great learning to sit together with process people who take care, for example, of the heat exchangers, then with the process people who take care from the cooling towers. So there are a lot of departments that take care of specific items, and those need to sit together and to talk to each other, explain what helps them to improve their process from the water perspective. Without that learning, we would not have been able to bring this setup together.
Great, lovely. Thanks very much, Joachim. Again, there are
Welcome.
a number of questions which will be forwarded to you, but we're running late, so we're going to have to move on. Great thank you to you. Great thank you to all of our presenters for the revealing insights that they've given us. And thank you to the very large number of people that we've had watching this afternoon. We're going to move on now, and I'm going to hand you over for a panel discussion, which is on the transition to a circular economy, creating significant synergies for the wide adaptation of water reuse as an alternate water supply. The panel are going to be talking about how we overcome the barriers to water reuse from public perception to pricing and technical challenges. And it gives me great pleasure to introduce as the chair of the panel, Mr. Rajneesh Chopra, who is the Global Head of Business Development at VA-Tech Wabag. He's a board member of various subsidiaries and joint ventures of the company, and he is at the forefront of generating growth and profitability from many of their operations. So to introduce you to the panel and to the discussion, I would like to hand over to you now, Rajesh.
Thank you, Mark. Thank you so much. And thank you for that introduction. See, I think I saw some of the presentations just now. They were very, very interesting. And I can assure all the people who are watching us that, this panel discussion is definitely going to throw a lot of insights, because we have a very, very balanced, panel here, which is representing, the urban local bodies, the government perspective, the policy, the regulation, the technologies, the implementers. So probably it's something, which looks at, when we talk about a circular economy, probably this is a panel which is going to give us, a 360-degree perspective about how do we go about implementing the whole scenario of water and wastewater. I would just like to mention here that, today we are all going through a very, very tough phase. We say it's an unprecedented phase of COVID-19. And water and sanitation has taken a phenomenal place in the minds of all the governments, the decision makers, the industry, because water has become a prerequisite for sanitation. And especially when we look at developing worlds or like India or some underdeveloped countries, probably this is something where it is a much different situation compared to the developed countries, where it is available in abundance today. So this is a very appropriate time to take up this topic. And I really appreciate that, this topic has been taken at this point of time. Also, I would like to mention here that, we all are committed to, the Sustainable Development Goals, that is SDG 6, water and sanitation for all by 2030. So all put together, it's going to be a very, very interesting session, which is going to throw a lot of lights on the issues and probably what are going to be the solution. So I would like to introduce the panel. We have Dr. Ajit Salvi, who represents, the largest municipality and probably the richest municipality of the country. And he's, heading the Mumbai sewage disposal project, which is by and large, probably one of the largest sewage disposable project, not only in India, but across the world. So I'm sure we will listen something very, very interesting from him. His presentation has already spoken about his project. We also have with us Anil Kumar. I think he's from RHDHV. I think he spoke about Singapore in this panel, and probably we would look forward to his views that how, we can take the learnings of Singapore and look at how do we implement it in this country. We have Mohammed Salaf with us. He represents one of the largest, infrastructure players, Larsen and Toubro, and he is a process expert. So one of the key things is there are a lot of technologies, there are a lot of, what is interesting is, like companies like Wabag and L&T, probably one of the core strengths we bring on the table is integration of the technologies to achieve the desired results. So I'm sure he will throw light on that. And also, we have Mr. Mukesh Kulkarni. I think he represents DuPont. We already heard about a presentation. That is one organization which is looking at innovation, which is looking at R&D, and probably they can give us the solutions on the technological front on whatever challenges we are facing, both in municipalities as well as industries in the country. So I would like to start this conversation by requesting each of the panelists to give their views on this water reuse and recycle in the circular economy. And I would like to start with Dr. Ajit Salvi. Over to you, Dr. Ajit Salvi. I'll request everybody to restrict themselves to 5 minutes each so that we can have more interaction.
Definitely, sir. Thank you for the introduction. Lots of discussions already done in our presentations and all, but still we are talking about the recycle and reuse of water and circular economy. To be very frank, everybody is well aware about the water stress countries and water stress all over the world. See, one of the research material during my what I published, there is a data. It gives that in 1995 there were 31 countries which were water stress and which covered around 40.46 billion people. And in 2025, it is expected that 48 countries will be water stress and almost 2.8 billion people will be suffered due to water stress and all. Say in by and large, everybody understand there is a problem about the water and water stress and everything. Definitely, I always say, chemically speaking, H2O, very simple chemical compound, but no one can artificially produce that water. That is not possible. So what is the way out is what, one of the ways is what, see, we can have a smart water management system. We can go for desalination and so many things. So out of that, one of the aspect is what? Can we go for the recycle and reuse of the wastewater, that is treated wastewater? And to be very frank, this is during our discussion, even Anil Kumar is so rightly said, why not to change our terminology rather than saying wastewater, is it possible to use the terminology as a use water? So that is the one aspect, because that is very much needed in India. Otherwise, as I said in my presentation, yesterday's water is considered as a stale water and people are throwing it. So this is not a good thing. So wastewater is a sustainable resource, and with the proper treatment and all, rather than developing new facilities and new infrastructure for the fresh water, it is always better that whatever resource 24/7 available in the city, is it not possible to use that? That is the one aspect. Second is what, to be very frank, generally in mega cities like Mumbai or any other city, there is a one trend you see that for taking the water, fresh water, people are going away from the city. As in Mumbai, we are bringing water, fresh water, 150 kilometer far from the place. That our dams are located 150 kilometers. And after using that as a decentralized system or centralized system of the wastewater treatment, again we are taking it back to the sea, and that is also, there is a lots of conveyance system is there. So point is what, developing new water project at a further place, is it not possible to use this wastewater as a resource? That is the one thing. Second, it is not only a wastewater, but only a recycled water. But apart from that, there is a sludge. Out of sludge, we can develop manure. We can take nutrients out of that. So particularly in developed countries, they take out ammonia, they take out phosphorus. So all this aspect, definitely, so far India is concerned, it will go slightly, it will take some time. But this can be a probable, ideas we can think about as a circular economy. No doubt about the biogas and electricity, all this can be. My point is what, in a given time, I will conclude in a one line, rather than saying wastewater treatment facility, is it not possible to talk, or rather than talking about sewage treatment plant, is it not possible to say that this is a factory and from where we are getting some revenue out of that? It is revenue we are out of that. So this concept should be over a period of time. We should proceed with this concept, and that will be the thing. Thank you, sir.
Thank you, Dr. Salvi. Thank you for that very, insightful observations to begin the whole conversation. So first of all, I'd like to apologize. I think I wrongly spelled, the name of Mahesh as Mukesh. So my apologies for that. He's Mahesh Kulkarni. Now I would, request Anil to speak about, his views on, the reuse of water, especially, looking into the circular economy concept, with special emphasis on India.
Right. I think, as I said in my session, like there's a need of developing a policy and framework which is in the need of the hour requirement. From it starts with the leadership and the government side, and those policy frameworks are already in place, and government is progressing very fast into that. And there are some aspects of done by Niti Aayog also on these areas. With respect to Maharashtra state, there is a industrial policy to reuse the wastewater, and many other states have similar policies. So this policy framework is already in place in various institutions and government bodies. Now, coming to the urban algorithms, the way urbanization is going on in our metro city, we need to identify what is the end use of this water, and what are the social consideration involved with the use of this water, especially how public will perceive in terms of consuming this water, and how the will govern the various technology which are available in various reuse and recycle programs. Second point I would like to add into land availability. That's another challenge Dr. Salvi has mentioned in his presentation. Based on the land availability, the technology selection play a key role into that. How technology is going to be selected, and it's a very cost and a lot of logistic issue also involved into land selections, and how implementation process should happen onto land availability. So we had some great examples shown by Dr. Salvi. What are the plans in Mumbai city, which is quite challenging. The third aspect is land use and land cover. How the urbanization is happening, so that this complete water recycle and reuse can be sustainable for that land use cover. If it is an industrial township, then definitely the indirect I would say potable of water can be done, indirect use can be done. If it is for the domestic water supply and recycle reuse cases happening, there are few examples like Delhi government is initiating in I would say coronation pillar, where they are adding treated wastewater with the source, similar to what Singapore government has done. So a lot of investments are happening within the cities itself. Then fourth point is public acceptance. How public foresee this indirect or direct use of water. That is also very important aspect where one need to spend time, including leadership also should play a key role, what many other countries have done in the past. Fifth point is demand versus supply of the sources. We need to work in an integrated manner with respect to the demand and supply of these sources, and how we can integrate these sources to have a circular economy concept into our cities. And lastly and most important for a country like India, fund availability and willingness to pay by the public. That is also important because we are into a country where cost play a key role, and I see a lot of questions raised by the many participants on the cost aspect. And as we are moving forward, you might have observed last 15 years, the cost of treatment of wastewater is going down with the best technologies what we have. So, and willingness to will play a key role, because as I said in my presentation, people are happy to pay top up of their mobile phone. but and in fact buying a water bottle of 20 rupees, but they are not willing to pay. So that level of awareness is required into the societies. With that, I would say thank you very much. Yeah.
Thank you, Anil. Thank you so much for those observations. Uh, I think there are challenges, there are issues, but I'm sure we have a very very
Yeah.
balanced panelist. As I said,
Yeah.
there are people who are here to offer solutions also.
Yeah.
So I would request Mohammed, to take up the floor and talk about what are the kind of solutions which can be offered to offset the challenges which probably the urban local bodies, and as Anil mentioned, because he looks into the sector very deeply and intricately, that what are the challenges and how we can offer them solutions.
Thank you, and I would like to welcome other panel members and the team and the people who are watching this webinar. I would like to maybe about years, maybe 20 years, 25 years ago, the technology for the wastewater treatment plant was dictated by what is the end use for that effluent. And if the effluent is for reuse, the technology that the municipality adapted was technology which would provide a reuse quality. But right now, if you see last 5 years, even in India, the quality of the wastewater treatment plants became more sophisticated. We've got SBRs, MBRs coming into the picture, and those technologies they came to meet the effluent requirement, which is very stringent. It's getting more stringent day after day. So in the past, what you want to do with the wastewater was dictating what technology you use. But right now you have no choice. You have got NGT norms that came out, other things which made the reuse quality to be produced by default. A reuse quality to be produced by default. That puts the municipalities and the government bodies to think again and say, look, we already have good quality water. What are we going to do with this? And that will be the beginning of the reuse. The beginning of the reuse. And the reuse always must have a economic sense, must make economic sense. If it doesn't make sense, economic sense, no one will do it. If you look at in India, the industries, they are the ones that actually implement water reuse, wastewater reuse, without anyone telling them, because it makes economic sense for them. They have to meet certain norms in terms of treating the effluent, and once they treat that, they compare with the water that they're going to buy and the water that they generate, and they find out most of the time that the water they generate is cheaper, and they use it. But the municipalities, the norms were a little bit lax. It was, let's say, BOD of 30 or TS of 30. You really don't have much to do with that. But right now, we are getting a total nitrogen of 10. We are getting a tertiary treatment, so on and so forth. So the water that's produced right now is very good quality. So the government has to think. The government, municipalities like MCGM and others, they have to think about what we're going to do with this good quality water. Are we going to just dump it, or we are going to sell it to the industry or make it in economic sense? In a sort of waste, shall we convert this one to a resource? I think that's where we are right now, and I think, and that's where the technologies, the sophistication is coming into the picture. More membrane technologies are coming into the picture. More tertiary technologies are coming into the picture, and in areas of India where there is a water stress, in Tamil Nadu, for instance, that's where people are looking at how can we, take advantage of the wastewater, treated wastewater, for drinking purpose and so on and so forth. So I think the direction I see in India it's in the right direction. Things are moving in the right direction, and I think the municipalities now, they just have to realize that this is a very important resource to be wasted. It's not to be wasted. There's already a significant amount of money went into that, and to reuse that is more efficient than to to put stress on the existing water resources. That's what I would say.
Thank you, Mohammed. Thank you so much for your initial remarks. So with that, I move on to Mahesh. Probably he's the guy who carries the final key, that how technology can help us, all the challenges, the technology and innovation, which is the key things which he represents. And probably if I look at, he's designated as head for solutions. So probably that's one of the reasons probably we are, requesting his remarks. The last, probably he's got that magic key, which I'm sure he is going to share with us now.
Yeah, and interestingly, there is no magic key. So, but I heard a lot of speakers and our presenters talking positively, about trying to make the most out of it. I mean, whatever, whether it is a water treatment plant or a wastewater reuse treatment plant, and there seems to be a lot of focus now. When I look back at my career 20 years before, we were talking about groundwater treatment, or maybe to a certain extent surface water treatment. That still holds good, but I think the fulcrum is shifting, the focus is shifting. There are huge amounts of wastewaters, whether it's from the municipal bodies or whether it is from the industrial segment, which are there. And as everybody is suggesting, yes, I think there has to be a proper sort of feasibility study which has to be undertaken to find out that we have on one hand large amount of water bodies which could be treated. We have technological solutions, and we have maybe users for those treated water. But then looking from the technological standpoint and then converting into the commercial aspect, how feasible that is. And that's where companies like us and technologists like us come into picture in trying to sort of optimize the overall treatment solution, whether it is with respect to the energy conservation, whether it is with respect to maximizing the water recovery in certain cases, whether it is trying to produce water which is fit for reuse. So all these technological advancements have happened. There have been some global studies which have been shared. Obviously, it's very interesting that these global studies could be adapted into the Indian environment. Sometimes it works wonderfully. Sometimes we need to sort of modify it, tweak it so that it works in the local environment. But yes, I mean, this is a very interesting discussion which is happening, and we thank all the panelists which are there, to share their remarks. We thank you all the attendees as well who have been putting a lot of questions, and we'll try and sort of answer those questions. Just moving the needle ahead, I mean, initially there was a discussion about maximizing the water recovery, but we are also seeing a trend, not only globally, but in India as well, where the industrial segment is taking the lead in trying to sort of work in the direction of circular economy. So it is not only maximizing the water recovery, but maximizing something which is like a raw material to the consumer. Could we extract that as well with the help of various technological advancements, so that the overall cost burden on the user is been reduced. So that's how I'll sum up, and we look forward to the discussions. Thank you, Rajneesh sir.
Thank you. I think thank you everybody for your comments. Now I come back to Dr. Salvi. I think one of the key things, what is expected both by the citizens, the industry, is, when we look at the government, is two things. One is, what are the policy interventions and regulations which can help us, speed up the whole process of, resource recovery in a wastewater treatment plant. Also, there has been a question that as a country, do we have enough of resources to implement the ambitious plan, which most of the states are drawing today, for recycle and reuse? Because every state has, set up their targets, which have come with a recycle and reuse policy. So that is there. But one thing is there, from the questions which come, I think one thing is very clear, that most of our attendees, they believe that water is too precious to be used just once. So definitely there has to be a reuse. I'm sure Dr. Salvi will agree with me that probably if I'm looking at 135 LPCD to be achieved for a citizen in the urban areas in the country, not more than, 20 liters will go into, the real human consumption, and maybe another 30 to 40 liters will be where, human contact is there. So balance, it is all gray water and sewage which is generated. So there is definitely a lot of scope of reuse. So, but coming back to thing, and third is, today there are challenges as far as, land is concerned in urban areas. Now, one thing is, Mumbai has come up with certain plans which have been very, very well appreciated, that how you are going to overcome the land constraints. And also today in urban areas, there is no space available, no landfills available anymore for disposal of sludge. So how we can overcome that to make it a very, very sustainable and a robust model, which can be further implemented across the country.
So many questions. Anyway,
Yes.
I will try to answer the major which is related with the government or local body. So first of all, as you rightly said, or in the discussion we said, still people in India are not ready to go for reuse of the wastewater or treated wastewater. So in our municipal corporation, we have come up with some scheme, like if any of the bigger complex, if they treat their wastewater at their end and reuse it, then we are offering rebate in their taxes, in their assessment taxes. Finally, in particularly all people, if anything is connected with the money, they are happy to use it. So this is what some rebates we are providing. Similarly, particularly say for industrial use and all, the fresh water is supplied at a comparatively very higher rate. It can goes up to 50 rupees and above for 1,000 kiloliters, for 1,000 liters. So rather than if you are supplying this wastewater which is treated, we can supply them at a cheaper rate, comparatively cheaper rate, and still it will be beneficial to us. So if such type of model is developed, then definitely whatever central government guidelines are what, as per their service level benchmark, only 20% water has to be recycled at the beginning. But we are having an ambitious project of recycle of 50% of the water, and then over a period of time, then we'll go with the 100% of the recycle. So not a one night job. Definitely it will take some time for implementation and for understanding the people, the need for, as we discussed, it should be connected with the cost and pricing. Then only people will understand. That is one thing. Regarding sludge you said, particularly now it is in my discussion, some people may not, as I said, it is a factory. Some may not be agree with that. So it is not don't go with the theory. Idea is what? Wastewater is an input and we are taking out some of the ingredients, some of the nutrients from that. So if sludge is treated to the class A level, then definitely it can be used as a manure, it can be used as a fuel, or for so many other purposes. So it will not go as a harmful substance to the environment, rather than it will help environment or it will help earth to get the things back. So this is how we are planning for the sludge disposal. Apart from that, even we are the recovery of the biogas and develop our generation of the electricity, that is also possible out of the sludge. So these are the overall idea. That is what we are planning for and we are going for. So this is what my submission.
Thank you so much, Dr. Salvi. Now, one more question, which has come from one of the attendees is that probably maybe Anil can take this. What they are saying, rains in this country are abundant, although they may not be evenly spread. Would it be better to focus on rainwater harvesting and managing this water rather than the treated water?
I think both of us will answer, definitely.
Yeah.
See, sometimes, I will answer part way. See, rainwater harvesting is a good phenomenon. See, if you recollect, in my opening remark, I said for addressing the water stress and all, there are so many solutions. So in that, the rainwater harvesting is also one of the solutions. One can think about the desalination. That can be also a solution. So it is not for water stress only. If you go with the one solution only, that is what, let us say, rainwater harvesting or desalination or recycle and reuse of wastewater. That is not the way. We have to integrate all aspects, and we have to find out the best possible the way out, depending upon to site. Say particularly some of the cities which are near to the seashore and all, the rainwater harvesting is not that much useful. So this is what the general. I can Anil Kumar take further.
I think I agree with you, sir. Rainwater harvesting is another, I would say, source of the water. We have to, assess these all the water sources in an integrated manner. I
Yes.
mean, it will supplement to the, I would say, additional source in the city, and many initiatives are in place actually. I mean, it doesn't make any sense if we do rainwater harvesting in Mumbai city, which is near to the coastal belt, and a lot of challenges are there to in terms of space and land and other groundwater issues are there. But yes, cities like Delhi or northern part of India or some part of southern part of India, there it makes sense to to optimize the rainwater as a source. For example, like cities like Delhi, the government of Delhi has created some collection areas for the rainwater, where surplus water which is coming into the river, especially during monsoon seasons, Yamuna River, they are storing that water and rejuvenating the groundwater potentials, and they are using that water for now as an additional source. So these are the efforts in place by various other governments. Similarly, Bangalore has developed a lot of rainwater harvesting potentials. In fact, the city has gone into much advanced manner. Like 2 years ago, they have developed a rainwater harvesting master plan for the entire city in Bangalore. So these kind of initiatives are already in place. But yes, this is going to supplement as an additional source, and recycle and reuse also of the treated water will act like as additional source in the city itself.
I think both Dr. Salvi and Anil, they have very aptly addressed the query. I'll only like to add that, when we talk about rainwater harvesting, I come from city of Chennai. I think here it is something which is mandatory here, and it has definitely helped this city over the years, the first city to do that. I think rainwater harvesting and recycled, if it is looked at integrated, in fact, all the water resources, not just that, whether it is surface water, whether it is sea water, recycled water, if all integrated approach, as both of you mentioned, that is the only way we can achieve our water security. And there is no other way. And secondly, rainwater harvesting, definitely we need to promote it. And I see that recently there is a initiative from Jal Shakti Ministry to create that kind of an awareness and plans by almost at every district level in the country. So that would definitely enhance our storage in the ground, which has been over the years depleting.
I think just to add into, they are going to up to village level actually.
Right. So
yeah,
that's something definitely we as a country we are looking at, but that is not a substitute. As I said, water is too precious to be used once. So definitely there is a scope for recycling all this water. And today industry, I believe industry gets only hardly 1% of the total water, right? And as Mahesh pointed out, industry has been a front runner in achieving a circular economy. Even as an organization, we have implemented very large projects in oil and gas sector, where recovery from the effluent has been as high as 90% and above. And also there is an energy recovery even in the industrial sector.
Yeah.
So I would like Mahesh to talk about a little more upon the latest technologies which the industries have resorted to, and that has helped them achieve their water security, because it makes commercial sense for them. It's loss of production there. So industries have, especially the large heavy industries, have been the front runners. So I would request Mahesh to throw some more light on that, both on technology and water security in industry.
Yeah. Thank you, sir. And it's a very interesting part, because industries definitely, as everybody is saying that, these supply to the industries obviously at a very costlier prices compared to maybe the human consumption. So industries try and sort of evaluate, what is going to be the optimized solution for, trying to treat their wastewaters because they are deprived of, the raw water sources. So looking at the various segments which have gone ahead, like Rajni sir spoke about oil and gas. We talk about refineries going for wastewater treatment. We talk about chemical industries. We talk about pharmaceutical industries. In some cases, some of the peculiar industries like textiles, which are generating a lot of difficult or challenging effluent, have actually been pushed to treat the entire amount of water, and they cannot discharge any amount of water outside. So this definitely, is like a sort of signal, to all the technology suppliers to try and find out solutions for them, which are not only going to be reliable, durable, but also in terms of cost, are going to fit, the bill what the customer is looking at. So from the technological standpoint of view, the different solutions which have been used by the industries, like whether it's going to be membrane-based solutions when we talk about ultrafiltration processes or membrane bioreactors. These have been predominantly used, but we see a lot of these technologies also used in the municipal wastewater. And as everybody is speaking about, trying to sort of find out a very sweet spot that, we try to treat the wastewater with a very cost-effective solution and trying to understand what's going to be the real use of that particular wastewater. For instance, if the water is going to be treated and if the water is going to be used for, say, purposes which are not demanding as high as for the industrial applications, obviously something like filtration can help them. And the filtration can start maybe from coarser filtration like a sand filtration process. It could go to as high end as maybe ultrafiltration process or maybe membrane bioreactors. And all these technological advancements which have happened primarily to try and understand that how we can help the customer. It could be from the perspective of trying to save the footprint. Everybody has talked about footprint, and especially metro cities like Mumbai, Delhi, Chennai. Obviously, land is one of the major constraints. So why not look at solutions which can save space? The important factor is obviously why not look at solutions which can save power, which can save energy. And when we talk about all these applications and all these technologies, one of the key factors which any technological advancement happens or innovation happens, looks at all these key ingredients. To move it a little bit further, when we talk about reuse or recycle, and we're trying to sort of address, the concern what the industry is trying to talk about, even the industries try and work them around, in a closed circuit manner, where they generate their own wastewaters and they try and basically treat their wastewaters and use this as, a water for their process application. So technologies like reverse osmosis systems, technologies like nanofiltration membranes have been developed in order to see that we deliver the right kind of desired output, and then at a manner in which the industry can afford it. When we talk about optimization, it could be with respect to the membrane surface areas, with respect to the energy. So all these factors are being taken into consideration. If we try and sort of push this needle further, when we're trying to talk about primary treatment, secondary treatment, and then maybe tertiary treatment. Now there are technologies which are also available, and in some sections industries have adopted this, which is like a thermal process. So it's going to be an interesting sort of offering, and it's a very very unique time for us to sort of look at all these different technologies and trying to sort of figure it out that how it could be put to best use. Everybody will have a different kind of a challenge, and everybody will like to see that what is the right kind of requirement for themselves, whether it is from the industrial perspective or whether it's from the municipal organization perspective. So from the perspective of technology, the technologies are there. We have to figure it out that how we can make the best use of it. And the innovation cycle will move on. I mean, when we talk about different kinds of challenges, obviously challenges will bring innovation with them, and it will be very interesting to find out that how we can use them in a way that it reduces the cost burden on the user.
Thank you, Mahesh. So I'll come to Mohammed now. See, one of the most interesting questions, probably Mohammed, which you can address is, people are saying that yes, recycle, reuse is there, but one of the major challenges we have in this country is on non-revenue water. So L&T being one of the largest players in the field, probably how we can reduce that NRW and enhance the water supply by plugging all the leakages, which can definitely help in generating more water out of whatever is currently the resources available. And that can definitely help us even produce most wastewater for treatment and recycle and reuse. So would you like to throw some light on that?
Yeah, L&T has done quite a bit about the non-revenue water. Non-revenue water in a lot of smart cities, municipalities, the non-revenue water plays a key role in the sense that the amount of water that's been wasted from the treatment plant to the end user is very significant. It's really very significant. And sometimes people would wonder how all that water is being wasted. Instead of thinking of water reuse, first you have to make sure that you maintain what you have. You maintain what you have, which is the water that you have already spent money to generate. And I think this is picking up a steam, not only in India, globally. It is and you will see a lot of technologies that have been developed to avoid loss of water. Governments, municipalities, everybody is spending money to ensure that the quality, the amount of water that has been wasted is recovered. And I think that's a good place to start. A good place to start is to make sure that we maintain that, and the technology is available. And a lot of people are working on this right now. And I think we were discussing about the water reuse, but first we need to maintain what we have. If we lose that amount of water, and I know I live here in Chennai, and water is very precious. If it doesn't rain, we don't drink, and basically that's what it boils down to. So if you lose that water, it will be a very, very big challenge. So I think even though this is not in the water reuse, but I think this is will fall in the realm of water retainage. We have to make sure that we retain what we have, and there's a lot of technology, like I said, is available, and it makes economic sense, a lot of economic sense to have a non-revenue water recovery. And this is a growing trend globally. A lot of software been developed for this purpose. A lot of instrumentations have been developed for this purpose, and L&T plays a very key role in this.
Thank you, Mohammed. So now I will move on to the last topic, which is always a very, very controversial one, which is about the right pricing for the water and treating it as an economic commodity. So I would like to start this with my comments that, see, we implemented one recycle project for Chennai Metro, which is 45 MLD. The entire supply, it has a UF, it has an RO, it has a latest ozonation, and it's treated to drinking water standards, but not used for, it's only being supplied to a SIPCOT area for industries. Definitely, Chennai is a water scarce city, so the industries are willing to pay more. And I believe they are charging around 80 rupees per meter cube. And the total investment of that project, as per Chennai Metro Water Board, they'll be able to recover in 4.5 to 5 years. So the payback period for the entire capex is 4.5 to 5 years. Now, other cities, it could be a little lower based on the current tariffs for the fresh water which is being supplied to the industries. So there is a model which is even commercially viable. So once it is commercially viable, definitely there is a scope for this to replicate. And when it comes to industries, we do a lot of projects for industries also. I think industries value water much more than what as individual citizens we do. Because for them, it is a resource, it is a raw material, and anytime they have a production loss, like one of the refineries, their head told me that one day your water supply stops because we manage the entire water block for them, my net loss, it is not talking about the revenue loss, he is talking about the net loss, will be 70 crores a day. So probably that is a kind of sensitivity which is there in the industry. So one of the way forward could be to make it more viable, reliable and sustainable, this particular recycle and reuse this, that more industrial and municipal partnerships can be forged. And secondly, I believe that there has to be a right pricing. My discussions with various multilateral agencies across the globe, I think one thing is very clear, that there is no dearth of funding available for the country. What is challenging is that they want that, yes, we will be funding for the capex, but we want a business model from the municipality where they can show us that they are at least recovering the OPEX. So I think the most appropriate person to comment on this would be again Dr. Salvi. I'll come back to him. And I'm happy that he's smiling all our questions, the maximum number of questions, with a big smile.
Sir, if you talk about the recovery of operational cost, today even I feel that forget about municipal corporation of Mumbai itself, but any of the big cities, if you compare the operation and maintenance cost of their fresh water, considering they are bringing all the far from the city and all, and then if you consider the operational cost of the treatment of the wastewater, still it is viable. Say, for example, I can put in a different way. As per NGT, as per say requirement of the environmental issues and all, say one has to do the compulsory treatment of what 1020, that is BOD 10, TSS 20. That is compulsory, and you have to throw it into the say anywhere, whether it is sea or creek or whatever it may be. So further addition of tertiary treatment, how much it is costing? So if you want to really talk about the thing, whatever the treatment we are doing up to secondary, that is what we are doing it not to harm to the environment. Okay. So this is what my way of thinking. And from secondary to tertiary, whatever additional cost we are putting, that can be considered as a recycle cost. And if we can recover that also from the say end user at the beginning, and if the use of the wastewater or use of treated water slowly increases, then also it is beneficial. And definitely whatever you are talking about, the model or say operational cost, it can be recovered. This is what the different way of thinking. Otherwise, if you add total cost of the treatment and try to recover from the common people, initially it may not be possible.
Right. I think excellent thought process, and probably this is the first time I'm hearing it, Dr. Salvi. I'm sure we'll request, Kailash to take it to the right decision makers, both at the state and central level. I think the way, if we start looking at it, it is really a viable solution and very much implemented.
Right.
Yes.
Now, I think Anil spoke about, pricing again. So what could be the right way of pricing? Because I believe as consumers, like I use an RO at home, I spend 6,000 rupees for an annual maintenance contract. We spoke about, using of bottled water. So any day water is not available to me, I order a tanker, which costs me 1,500 bucks. So as in urban areas, we are actually spending a lot for water. But probably one of the key things is that we are not willing to pay as citizens, or I would put it the other way, which is again becomes very debatable, is that there is no political will to charge.
Yeah. I think just to on the pricing part, I would say that there's a need to improve the pricing for generating the sewage with domestic wastewater, which is coming from the household. I remember when I was in UK, I was paying more for the sewage component than the pure water supply, drinking water supply. So we need to have a mechanism to improve the pricing situations, because many of our utilities are suffering because of revenue is not generated from due to various challenges we are coming up. And if I take an example of Delhi government, what they have done a very smart move of putting some component of water as a free, and charging the customer also on top of it. So that revenue mechanism they have developed, that they're actually getting more money from these kind of systems.
Hello. I think we lost Anil for a while,
Anil for a while.
and we can. So, Mohammed, what is your take on what could be the right pricing for water and treated wastewater?
Yeah, I think the right pricing, unfortunately, the pricing is a politically driven. It's a politically driven, especially when it's not privatized. If it's privatized, then definitely the private sector will charge whatever whatever price that they can make a profit. But when it's controlled by the government, whether it's municipality or local government, then it is mostly politically driven. If you're up for election next year, you don't want to raise the tariff for the water. So it's just a politically driven. But I think if you look at the West, for example, in the US, you pay for the water, you pay for the sewage, both, and it is privatized. You pay to the private sector, and there's no mercy. If you look in the Middle East, the expats pay for the water, but the local people, even though it's a desalinated water, very expensive to produce, they get it for free. So the price is the subject of a political will, and it depends on who is controlling the water.
Yeah, but I think whatever Dr. Salvi said, that makes a lot of commercial sense, as well as a lot of practical sense to implement the projects and recover the cost. Now, Mahesh, what would be your perspective when it comes to pricing from the industry?
It's as you rightly said, sir, it's a very debatable and a controversial kind of point. But then obviously, yes, I think we should not ignore it. Definitely, it should be one of the main sort of criterias when we work on a project. And definitely, whether it is the capital cost or whether it is the operational cost, I think both these costs put together, what the new terminology which is coming in the forefront is the total cost of ownership. So whether it is from the industrial perspective or whether it is from the any kind of a government perspective, I think one should look at the total cost of ownership, how it could be optimized with the right selection of technology, with the right use of technology. I think technologies are definitely there. It's up to us to find out that how we can optimize it, and trying to see that how we could reduce the overall cost environment. That's what I can summarize.
Right. Thank you, Mahesh. Thanks for your views.
Sir,
I think, yeah, please.
One half minute. Say, particularly, you can see that, just sake of example, we are providing water at anywhere. You can say not only music. Generally, I'm talking in general. Say 1,000 liter 4 rupees or something. Okay. Tomorrow, it is a 4 rupees per 1,000 liter, and people are ready to pay 1 liter 20 rupees per bottle water. That is okay. And as Anil Kumar said, for their recharging of the mobile and all. Okay. Now, if you increase, let us buy 2 rupees, okay, and make it 6 rupees, 4 to 6. Then the news will be like this: essential commodities like water, there is a 50% hike. Now, general public think that 50% hike means what? There is a rise by 50 rupees as such. This is how the people think about, and all sort of controversies takes place. So, as Mohammad Salah rightly pointed out, lots of political will is required, because at some of the even international conferences also, it was pointed out that water is an emotional issue, water is a political issue, and we have to deal it very properly, very carefully. So that is the thing. Anyway, I took some more time, sir.
No. No, you are absolutely right in what you are saying, but I think it is a fundamental right also. The
Yes.
Constitution gives me that it has to be provided to me. But I'm
Article
only
47.
yes. So all we are talking about is whatever is the conveyance and the operational cost plus the cost of maintaining the resource. I think that is something which, if as responsible citizens, we can pay. And what Anil, we lost him in between. Probably what he
I'm
was
sorry,
saying.
some
No
network
problem.
issue was there.
Yeah, technology has advantage and glitches both. So what he's talking about is a volumetric, tariffing, where lowest strata of the society, they get it for free, but as and when the consumption goes up per household, the tariff goes up. So that is one way where probably on an average a recovery can be achieved. So that is there. And just to sum it up, I think it was a very, very useful discussion, and I have thoroughly enjoyed it. And definitely all the panelists, they have brought to a lot of issues a different perspective, which I'm sure Kailashji would like to take it to the right people, the right decision makers, and they're taking a note of it. And thank you so much, everybody, for being here.
Thank you, Rajneesh.
Thank you so much.
Just to add a small line, like the water molecule actually doesn't dissolve in any of the pollutants actually.
Yeah.
The wastewater what you get from house or industry, the water molecule is actually free from any mixing of these pollutants what we add. So it is a technology which play a role to separate those ingredients what we add into the water.
Absolutely, I agree.
Yeah.
Special thanks to Rajneesh sir for nice.
Thank you, Rajneesh.
Thank you. Thank you, everybody.
Special thanks.
Thank you. Thank you. Bye.
Thank you, Rajneesh, for moderating this session. I will take your suggestion of taking it to the right people forward. Just to share, we have a request from Mr. Velrasu's office that he wants a recording of today's session. So we will definitely be sharing this with the right people. So thanks to Rajneesh, to all the panel members for taking time out and doing this wonderful panel discussion for us. Today we have received the maximum number of questions, and we will share these questions with all the panel members and our presenters, and we'll ask them to reply to your questions. Most of the questions were around sludge management and Class A biosolids. I just want to share with all our attendees that tomorrow, which is the last day of India Water Innovation Week, we have a special 2-hour session dedicated exclusively for sludge management and biosolids. We have presenters coming from Thames Water, we have DC Water and Drylet US, who are going to talk about their experiences of how they have handled specifically the issues around Class A biosolids. So with that, I request all of you to please do join us for the last day tomorrow. And with that, with a special thanks to all the panel members and speakers, I bring this day 4 to a close, please. Thank you.